Hi everyone. So my name's Tom. I'll try and be as quick as possible, get you to the beer as soon as possible. We don't want to keep network engineers away from their beer. I'm just another dude off the internet. I'm a jack of all trades, but network techie at heart. My day job is at Multiplay, and we make game servers appear all over the world. Anything from a tiny Minecraft server to big AAA launch titles like Titanfall 2, if any of you have played that. So we just make game servers work. I'm responsible for 35028, so that's me and my team. And of course, I'm ISO 3103 certified. So for any of you that don't know what Insomnia is, that's my other day job. It's a big gaming festival in the UK, 4 days of essentially celebrating gaming. The media have kind of referred to it as the Glastonbury of gaming. So for those 4 days, we do everything from a LAN party, a stage show, an exhibition. And over the years, we've kind of grown from tens and, a couple of people essentially in a village hall to thousands and thousands of people turning up at our shows and just enjoying gaming. Insomnia's run over sort of 5 different venues in the UK, from, as I said, village halls all the way up to the NEC where it is now, so the biggest event venue in the UK. I'm going to talk today about the BYOC part of the show, which is essentially where up to 3,000 to 4,000 people bring their computers along, plug into a network that we run, and essentially enjoy themselves uninterrupted for 97 hours of gaming. They have 24/7 access to the show, so they can literally sit there in their pants for 97 hours. They get food and beer delivered to their desk, so they can do whatever they want. Oh, and yeah, we build the network in 1.5 days for that. So on to a bit of the techie stuff. Yes, like all good networks, we still use 6500s. I'm not sure that's entirely true anymore. Please don't judge us. The reason for this is the kit that we've got is hand-me-down from our data centers. You can imagine what my budget discussions are like when I go and ask for £250,000 worth of routers, which I use for 3 weeks a year. So basically, I do with the hand-me-down kit what I can. We use 3560Gs for distribution and Extreme in the access layer. Every one of these clients, of these 4,000 clients, we give a 100 meg port as uplink to our network. So I thought I'd talk a little bit about the connection between us at the NEC and the interwebbles. It's really, really hard to get this bandwidth for just 3 weeks a year. As you can imagine, we've got all of the usual requirements that venues have of stuff that's on site and actually physically getting glass there. But obviously, if I go into an ISP's kind of sales droid room and say, can I have a 10 gig port on pay-as-you-go, I get laughed at. So we have to deal with kind of what's there at the venue and also what we can use. We've obviously got quite a large bandwidth requirement for a show of 4,000 to 5,000 gamers. So we've got to try and get big ports when we need them. We started with a 2 meg ADSL line in the Newby Grandstand way back in the day. We only allowed IRC to the internet, and that was when you could actually play a game on the LAN together. Floppy disks had copies of the games on, or maybe even CDs at that time, and you'd go and share it with your mates. Nowadays, it just doesn't work. As we moved up kind of through various different event venues and various different MIA circuits, we landed at the Ricoh Arena, where we were really lucky to have WarwickNet on site, who had glass directly into the venue. We had a really nice discussion with them and built up quite a big relationship, and essentially ended up helping them test their new 10 gig metro ring. So we had a 10 gig port delivery, and we put some traffic on that. We had quite a funny conversation with Ben at WarwickNet when we first turned up the port and put a bit of a test on it, and he said, "Oh, you really do use 3 to 4 gigabit?" And I was like, "No, that was just a test." And he soon realised, and we built a really close relationship, and we're really lucky to have those kind of providers that we can work with. And finally, we've ended up at the NEC, where we've got a 10 gig bearer with a policer, which we just push up and down based on the number of attendees. And the reason for this is that we can only afford a certain amount of bandwidth by not charging people a ridiculous ticket price. So we just kind of push that policer up as much as we can afford to do to kind of keep the cost as low as possible. So I want to talk a little bit about how we actually try and save some of that bandwidth going to the internet. One of the big problems we identified was that 4,000 people would turn up, plug their computers in and go, "Oh, my mate bought that game and I didn't." And so, of course, they click buy to buy their game and play it with their mate, and of course then becomes a 10 to 15 gig download minimum for a game. Times that by 5 games maybe that everyone wants times 5,000, and you get a lot of stuff you've got to download. You can see there from the traffic graph, when we open the show, we get about 4.5 gigabit a second, and this is out of our device that we've got. I'll tell you about that in a second. For just literally 4.5 gigabit a second of game downloads. So the way we thought about solving that is by putting a cache in place. We tried various different things over the year, but we eventually settled on this thing that we call Lan Cash. What it is it's an x86 box running Nginx, 2U Supermicro chassis, a buttload of RAM and CPU, and 8 1TB SSDs, and a 10 gig NIC in the back. When a client makes a request from something like Steam, which is a big game download platform, what it normally does is pull an A record for a content server like content1.steam.com, and then obviously goes and gets its data. What we do is we spoof those locally, a big list of all the different content providers. We serve a record for just a local address, which actually ends up in the back of this Lan Cash box. Its chunk, then if it hasn't got it, it goes and grabs it from the internet and then serves it locally just once, and then the rest of the time it just serves it locally. What we actually find is that people go to download a game and they're like, wow, that's pretty quick, and it's actually their local disks in their machine that are the bottleneck, and they're not the network. And it also saves us 4.5 gigs worth of internet capacity, which is pretty awesome. The hit ratio is really good too. For the last event that we just had, we downloaded 9 terabytes of games from the internet, and we served 60.5 locally, which is a 670% hit ratio on our caches, so that's pretty good. Anyone that wants to play with that or look at it, code's available on GitHub, and it's on blog.multiplayer.co.uk. Yeah. So we've always had publicly routable IP addresses at Insomnia. Obviously, Nat is evil. I can say that thing, everyone does. But the reason for that is because the internet has changed a lot. Well, in fact, even back in the days it was. Centralized game services really dislike Nat. The reason for that is kind of obvious. If you've got 4,000 people behind a network, behind one IP address, trying to connect to World of Warcraft's online servers, they get pretty fed up with you quite quickly. And also all of the big software as a service houses, the Googles, the Facebooks, all of that stuff triggers 2FA if you've got too many people behind one IP. So we give everyone a publicly routable IPv4. In the past, we've used V4s attached to MIA circuits that we've had. Neil, if you're in the room, there's still a /21 assigned to us for a circuit that doesn't exist anymore. And more recently, at the NEC, we have our own IP address space, which we advertise via BGP at the event itself, and we just give everyone a V4 from our own allocation. Yes, Rev K, I don't think he's here today, but we are fully dual stack. So we give everyone both a V4 and a V6 address. That was quite hilarious, actually, when we implemented it. We didn't really have any problems with the actual implementation of V6, but we got quite a lot of confused people coming up to our support desk saying, I tried to ping Google and there's like colons and stuff. Have I been hacked? So there was a little bit of kind of user education, maybe, where these people just don't see it on their home networks. Most of them are quite techie and stuff, so they know enough to get into trouble, but not enough maybe about how these core kind of things work. But seriously, I just want to emphasize, we literally turned on Slack stateless auto configuration on a few SVIs, and it just worked. There was no problems, so you guys should just go out and do it. 30% of our traffic was immediately V6, but that's all thanks to Google and Facebook. So. Sometimes we do run out of V4. Obviously, we do not have the biggest allocation in the world, and we do have 3,000 to 4,000 people that we've got to give IPs, plus exhibition space and stages and all that kind of stuff. So we are not fairly heavy, but we've used a few times the RIPE temporary allocation system, which is an awesome thing for any LARs in here. I've heard it mentioned in some UKNOF talks in the past about how maybe it was a bit of a clunky process, but actually it's really good. They seem to make super sane, sensible decisions. We literally just filled in a form and got almost an immediate response saying, yeah, no worries, have some address space. So yeah, you've just got to pay your RIPE membership and become an LAR, and you can just apply to have some IPs on a temporary basis. I think it's 30 days or something like that, but yeah. The only problems we have had with this process is not to do with RIPE really, but it's mostly around GeoIP. So we, the last block we had came from, or had just been previously used at the CCC hacker conference in Germany, and it just meant that when I turned it up and advertised it to the world, like everything was in German, Facebook didn't work properly, and I couldn't get onto BBC iPlayer, so we had to go and chase all of the big GeoIP houses like MaxMind to get that updated quite quickly. If anyone knows of a way to like some sort of GeoIP foo to make that work, please let me know, but it was a bit of a nightmare otherwise. So from the internet to the LAN, we obviously have some stateful firewalling. We are heavy users of Pfsense for this. We've used it for years and years. In fact, we used PF before it had a shiny web interface back in the day. We've always used x86 hardware for this. We just install Pfsense and off it goes. We've gone from 100 meg, 1 gig to 10 gig, various different 10 gig NICs, and more recently we're on Pfsense appliances. We use it just as a stateful firewall, really, and it doesn't do too much anymore now that we're not upstream bandwidth contended. But in the past, we've used it quite heavily for its traffic shaping features, where we would essentially bit bucket the web and 443 queue, so 80 and 443, and then we would essentially prioritize known gaming ports to make sure that people at our shows could always get on a game first. We've used these firewalls, Pfsense specifically, in active-passive configurations before. But we've had a few problems where a lot of our traffic is UDP and therefore really tiny packets, or not therefore, but is really tiny packets. We therefore have a lot of states on our firewalls. We had a problem whereby we had a gig NIC connecting the active and passive firewall, and we literally pegged a gig NIC in just state sync. That obviously came with a load of CPU hits and stuff as well, so we soon had to move to a kind of active configuration. So our layer 1 issues are slightly different to some other people. Firstly, we've got to get this kit to the venue before we even plug any cables in. Everything's got to go on a van, and it's got to be thrown around the motorway and that kind of stuff. So we flight case absolutely everything. We get custom flight cases made for all of our comms gear. It's quite difficult getting a custom flight case for a 6509, but we managed to do it. Sometimes things go wrong. This particular time we were going to a show and we had to get there that day. This Arctic lorry turned up with a broken tail lift, so we had to bribe a local farmer with some beer to actually get our kit to the venue before we'd even started. Sometimes, and when we get to the venue, we need to get this equipment around. So there's me taking my router for a walk, as you do. These sites are massive, and just getting this big comms kit around is actually quite difficult. This particular data center comms cabinet was on a first-story floor, which only has a flight of steps up to it, so we had to put it through a window. And obviously, for anyone that's not in the WISP kind of game, installing routers with climbing harnesses was a bit of a novelty to me. So once all the comms kit is out, we've obviously got to get the cabling in the floor. We're really lucky to be able to use the structured cabling in a lot of venues that we work with. We use single mode and multi-mode fiber between the core and distribution just to kind of get around the venue. And then once we are at the distribution layer, there's actually at the NEC and some other venues big tunnels that run along the event halls. In that we can kind of stick our distribution switches and then cable via Cat5e up to the surface. For anyone that hasn't installed Cat5 with a pickaxe before, you should totally give it a go. It's awesome. I want to give a little shout out to Flex Optics here, who uses our optics vendor. The reason why they're so important to us is because obviously we haven't got tons of money to spend on lots of different optics on multi-vendor. So we have this lovely little coding box that we can just change the optics when we need to. It might not be revolutionary for you guys, but it really helps us out. So once we've got all that cabling actually in the floor, we've got to get some switches out. Now, this was a totally easy job when we had 10, 15 switches back in the day. We just stuck them up in a pile, had a serial cable and went tap, 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 and then wandered off to put the switches out. We got to sort of the 50 switch mark and we started to get really bored with that. So we hacked up a little TFTP server, which we'd give it a IP address and a host name. That would TFTP a config to the switch just locally in a pile. We'd clip, 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 but it was a bit quicker. And then we soon got up to sort of like the 200 switch mark, and we got very, very bored. So we decided that we had to automate it. So we had a few requirements. The first one must be that we must be able to put any access switch anywhere in our network. The reason for this is because they all go in and come out of flight cases, and they get thrown around, moved around, and we can't guarantee that if we pre-config them that a certain MAC address will go in a certain place. And we just didn't want to have to worry about that. So the second requirement was that we must be vendor agnostic. We're already multi-vendor, but there's no reason why we wouldn't change vendor in the future. And the third one must be that it must fit in with our current network planning spreadsheet, which is Google Docs. Firstly, I want to thank Nat Morris for the original idea of scraping stuff out of Google Docs and whacking it into a local little database. We actually stole part of the Python code off of the EMF camp repo just to kind of prototype. We've rewritten that now, but it was a really good idea. So with those requirements, Giles Davis created AutoLAN. Now, AutoLAN is what we use to essentially provision all of our access switches and now our distribution switches in our network. What we do is we give every single switch a specific VLAN with the same IP address. We then go and put all of our switches out and do all of our cabling, and we press a button on our AutoLAN server. What that does is it does an ARP, and it grabs all of the 200 responses that come back, and we store those MAC addresses in an array. we grab the first MAC address out of the array, set a static up and do a CLOG in it to grab its kind of version and make so we know its model. We then do an SNMP request with its MAC address to the core router, and we say, where is this MAC address? And it gives us a port back, which we can look against our Google Sheet to say it should be connected to so-and-so distribution switch. We then go and query that distribution switch and say, right, where's my access switch? And it says on port 17, which we know from our spreadsheet should be called access switch 123. We've then got all of the information we need to build a config. We do that, and using the static up, we TFTP the config to the switch and reload it. We then move on to the next MAC address in the list, and we keep going until all of our switches are automatically configured. Now that's awesome because it means that we can put any switch anywhere. We're not reliant on a particular vendor's or an open source bit of software that only works on a particular switch must have a certain config. But there's also two other really, really awesome things which we didn't quite think about, which is that, one, we now have a really, really good list of state for our switches, so we can create things like monitoring configs really easy from it. And the second one is that we can replace a switch really easily. Once we just put a new switch in, it goes, oh, there's a MAC address that I wasn't expecting on this port. Would you like me to reconfigure it? We hit yes, and off it goes. That's turned a switch replacement from about 2 minutes to from about 15 minutes to about 2, which is really, really cool. We then moved on, and recently Zoe Lowe wrote some extra code to configure the distribution switches automatically, and we're soon going to add functionality to do the core, so it should be that we can do this for every single switch in the network. So I thought I'd talk a little bit about the things that go wrong. On the left there we have a rather unhappy looking 6509. That was when it came off the back of a lorry and it was looking rather smushed. There was some quite nervous twitching from me, and during the diagnostics on that one, we obviously do have redundancy and spare chassis, but it's never nice to have your primary router get smushed up. And on the right there, a rather unhappy looking 63 amp 3-phase, which decided to have a bit of a moment. It does raise a very valid point there, which is the network team are often the quickest on site to power failures, and the reason for that is because the magic pixies aren't passing, and therefore neither are the packets. We get there quick because our monitoring's better. So this is our kind of famous phrase within the team, which is, yeah, that'll do, gig. It's a bit of an ingest comment. We all know about bend radiuses and for fibre and copper in the data center, and yes, I love to adhere to them, and we do when we put this gear in, but obviously it's a live event, stuff moves, people kick things, and this stuff does happen. This particular cable on the right, okay, yeah, it's only a sheath fault, but that was passing gig for the entire time, absolutely fine. These cables take a lot more than you think they're going to. We've pulled zip cord fibre in stupid directions, and it's passed traffic absolutely fine. Okay, yes, the loss is probably a bit more and stuff, but these things take more than you think they're going to do. So a few more things about what goes wrong. I'm going to talk about DDoS first. So obviously we're a gaming show. Distributed denial of service is a thing that we're kind of used to. In the past we've used all of the usual mitigation techniques, the null routes, the RTBHs upstream black holing with your carrier, and ACLs from carriers. At the NEC we're actually really lucky to have fairly huge mitigation capacity from NS Focus guys who operate a cloud platform, and they have a little signalling box on site that monitors our flows, does threshold-based alerting, and then advertises a /32, scrubs it, and sends it back to us. We actually use Carrero as well in our online data centers. You should check them out because they're really awesome for low latency inline scrubbers. We are quite lucky to have quite a close relationship with the ISP that we have at the NEC. We've literally in the past seen attacks directly to our link nets, which is kind of annoying, especially when you can't really do anything about it at the show other than phone someone at the knock and say, help. So we've got ACLs put in place that protect kind of our link net IPs from the usual SPAF, which is kind of cool. Obviously, we've seen some switch faults. That one, by the way, totally cool at passing traffic, no issues, but I thought I'd better take it out of service because it looked a bit smushed. That one got run over with a pallet truck. That was kind of upset. And we've seen the other plethora of kind of line card failures, router bugs, firewall failures. The way we deal with that is by having lots and lots of spares on site and 24/7 engineering cover. TAC is just not quick enough for us, so we have to provide our own. Other issues we've seen on the left there, N and +1 cooling failing at the same time, so that sucked. We had to go to Speedy Hire and get some very quick portable aircon units and some fans to cool that one down. And on the right there, me pulling out a fibre after the event and finding some brown water. That wasn't too fun. We now call that fibre smelly fibre. We keep it around though, because 200 metres of zipcord isn't cheap. So a bit about fibre. At the venue, we're really, really lucky to have quite close working relationships with the guys there. We use a mixture of their structured cabling on site, single mode and multi-mode, and we also use this pre-term zip cord in barrels. You might ask why we don't splice and use proper fibre on site, and the reason for that is that it's just one less skill we don't need to teach all of our volunteers and engineers, and it means that we don't have to have an expensive splicer and stuff, so we just have it on the reel pre-term, and then we can just pick the reel that's good for the run, and off we go. Oh, on the right there is Giles's patented fibre spools. And a couple more temporary installs. So a nice one on the left there, which is a load of cable ties holding some CCTV up, because, you know, why wouldn't you? And on the right, we didn't really want to put the access point on the floor, so we just thought we'd stick it to the wall with some gaffer tape. I could talk about what we do at the Insomnia for hours and hours and hours. Well, have a chat in the bar, I'm sure, about some war stories. I just wanted to say a quick thing. A lot of volunteers go into making these shows and helping them run, as I'm sure is the same with UKNOF. These guys are incredibly intelligent engineers, and they just come and help us out to do cool things. So thank you very much, guys. And obviously the fibre on-off switch, that it genuinely does actually physically isolate a fibre. I have no idea why it's there or what it does, but we found it whilst walking around one of our venues. And of course, guys, just before you go to the bar, just remember, yeah, it'll probably do gig. Oh, by the way, a seasoned network engineer, if anyone can spot him, is in this room. Any questions? I suppose you better get some beer then.